Okay, for the first question, explain the meaning of differentiation and what are the techniques of differentiation. Differentiation is a process of finding the derivative of a function. The derivative represents the rate of change of the slope of a function at a given point. In simple terms, it tells us how a function changes as its input changes. For the techniques of differentiation, first we have power rule. Power rule is to differentiate a single function. To use power rule, we will take the power and multiply it by to the number in front of the variable, and then we minus 1 to the power. For constant rule, a number without a variable will immediately become 0. Second one is product rule. For product rule, we use product rule when we have two different functions in a single function. We label the first function as u and the second function as v. We differentiate them and label them as u prime and v prime. And we to get the result, we will use the formula uv prime plus vu prime to get the function of to get the result of the whole function. This is an example of the result. Next, we have quotient rule. We use quotient rule when there is two different functions, same as product rule, but one of them is the denominator of a fraction. Same as before, we label the first function at the top as u and the bottom one, the denominator one, as v. We differentiate them and label them as u prime and v prime too, but we use a different formula, which is vu prime minus uv prime over v squared. This is an example of quotient rule. Okay, thank you.
For question 2a, it was given to us 3x squared sec bracket s plus 2. So the u, we take the 3s2 as u. U equals 3s2, we differentiate it to 6s. For the sec bracket s plus 2, we take it and become v, and differentiate it for v prime equals sec bracket s plus 2 tan bracket s plus 2. So we are using the product rule. So the product rule, that is dy by ds equals u v prime plus v u prime. So we put the information in such u v prime v and u prime, and we multiply it like this for each number, and the answer is 3x squared sec bracket s plus 2 tan s plus 2 plus 6s sec bracket s plus 2. For the b, it was given to us y equals bx plus 2 divided by cos s. So the u is bx plus 2. bx plus 2, differentiate it and become 4. For the v is cos s. For cos s is v, and differentiate it become negative sin bracket s. So we are using the quotient rule. So we put the information. So the quotient rule is v u prime minus u v prime divided by v squared. So we put the information v u prime and u v prime, and we multiply it. So cos s multiplied by 4 cos s, 4s negative sin x, 2 multiply negative sin x, become 4 cos s plus 4s sin s plus 2 sin x divided by cos s square, and that's the final answer.
Question 3, given ln 3x minus e to the power of 2x plus 1 minus tan for y equals 0. Find dy dx using implicit differentiation. Right, we use the product rule, which is u of v prime plus v of prime. The u is y. When differentiated, it will become dy over dx. And the v is ln 3x. When differentiated, it will become 1 over 3x times 3. We'll get 3 over 3x, and simplify will become 1 over the x. And we put it in the equation, dy over dx equals to y times 3 over 3x plus ln 3x times dy over dx. And simplify it will become y over x plus ln 3x times dy over dx. And then we will simplify the e, which is negative e 2x plus 1 times 2 plus 0 because of the power, and it will become negative 2e to the power of 2x plus 1 because the 2 will bring to the front. And then we have 10 for y. When we differentiate it, we will become sec squared times 4y times 4 times dy over dx. We'll bring the 4 times dy over dx to the front, and it will become 4 times dy over dx times sec squared times 4y. And then we put all the equation that we differentiated all together, and we separate the numbers that have been times by dy over dx to the left, and the numbers are not included with dy over dx to the right. So we get ln 3x minus 4 sec squared times 4y times dy dx equals to negative y over x plus 2e times to the power of 2x plus 1. And we move the 1 times by dy over dx to the left, and it will become divide. So dy over dx equals to 2e to the power of 2x plus 1 minus y over x divided by ln 3x minus 4 sec squared times 4y. So that is our final.
For question number 4, they told us to use linear approximation to estimate the value of the equation above. So as you can see, the number is not suitable enough for both roots. So we're gonna change it into the nearest number to make it perfect for both roots. So we're gonna change it into 81. After that, we're gonna split the equation into two equations, which is fs equal to s with the power of 1 over 4, and gs equals to 2s with the power of negative 1 over 2. So we're gonna put the equation and put the new number that we have changed. So f81 equals to 81 with the power of 1 over 4. We're gonna get 3. So we need to find the f prime a. So we put the formula of f prime a, and we put the new number into x. So we're gonna get 1 over 108. After that, if we want to find fs, we're gonna use a formula which is fa plus f prime a in the circles x minus a. So after we put the number 1 over 108, we're gonna multiply by negative 0.001. So 3 minus 0.01 over 108. So we're gonna change it into points. 3 minus 0.0000093. We're gonna get 2.999907. After that, we're gonna do the same to the second equations. So we're gonna put the g, we're gonna put the equation, and we put the new number. So we're gonna get 2 over 9 equals to 0.222. So we're gonna put it into formula for the g prime a. So we're gonna put the formula prime a, and we're gonna put the 81 as s. So we're gonna get negative 1 over 729. We do the same as before. If you want to find the fs, we use the formula fa minus f prime a in the circles x minus a. So we put the number negative 1 over 729 multiplied by negative 0.01. So we're gonna get 0.01 over 729. So we change it into points. So 0.222 plus 0.0000137. So we're gonna get 0.2220137. After that, we're gonna add the two number of them. So 2.999907 plus 0.2220137. We're gonna get 2778. That's all from me.
In conclusion, differentiation is a fundamental concept in calculus that enables the analysis of how functions change. It provides powerful tools for understanding rates of change, slopes of curves, and optimizing real-world systems. That is all from our group. Thank you.